Welcome back everybody to section 2. Here we cover the types of faults. So let's get into it. Here is our first kind of fault. You imagine there is a crack in the ground here, this fault, and because of gravity or because of the earth pulling apart somehow, this block here just falls down, it slides down due to maybe tensional stress being applied here. Next kind is sort of the opposite kind of motion as the normal fault. So we call it a reverse fault. Instead, we have these two blocks. They've been separated by a crack here, but they're being pushed together, they're being compressed somehow. And so this block actually slides up past the other one. Next kind is a strike-slip fault. So we have two blocks that are not moving up and down necessarily, they are sliding past each other. You might call this a shear stress, grinding against each other here. Finally, you might hear about these things called thrust faults. Now, this is the same as a reverse fault, except instead of having a fault that's just going into the ground like this, kind of a higher angle, instead is a very, very low angle, almost horizontal kind of fault. Now, never in nature are you going to get this sort of 90-degree angle, right? You're never going to get a perfect corner like that. The fault is always going to be going a little bit not vertical, either one way or the other. And so you're always going to get this same shape, the same kind of geometry. Now, you might imagine that you are a miner here, right on the fault. And you look up and you see the hanging wall above you. You could hang a lantern off of it. And below you, you see the footwall where your feet are. So with every fault, we're going to have a hanging wall block and a footwall block. So now that we know what these terms mean, we can look at a normal fault and say, okay, well, the hanging wall here has moved down along the fault relative to the footwall, which we'll say has stayed still. For a reverse fault, we have the hanging wall, and it's actually moving up relative to the footwall. And you have this term here, the fault scarp. So as this hanging wall block moves down, it's going to expose a little bit of this block over here to the surface. A little bit of the fault itself, this thing, is actually exposed to the elements, and that's called the fault scarp. Now let's take a look at an example here. So I see a fault about right there. I can see that this sort of stripe was probably connected to this stripe at one time. So this part of it must have moved up. This is the hanging wall. The hanging wall has moved up, so this would be a reverse fault. Let's do another example here. So we can see our fault surface. We can see that this side, which is the hanging wall, has moved down. Let's see, if the hanging wall went down, that means this must be a normal fault. For the final example, well, I can see a fault here, cutting across the landscape, and I don't see any sort of up and down motion. Instead, it looks like these were moved side to side. One of them was pulled sideways relative to the other. So that would make this a strike-slip fault. Next section is seismic waves.